The computer that we know today are an accumulation of thousands of years of math, engineering, and understanding, where many people adding a small contribution to where we are now. The main eras of the evolution of computers can be of four advancement: the mechanical era, the electromechanical, where relays were used, the fully electrical vacuum tubes, and the invention of transistors, which were the game changers. The need of computer happened thousands of years ago. People at that time had to use their fingers to count, thus the 10 base number system. But bigger and bigger numbers were making life difficult. The abacus was created around 3000 BC by Egyptians to count somewhat large numbers and perform calculations like adding or subtracting and even multiplying. Counting the number of cows or crops were made easy with the help of abacus. During the first part of 1600s, the computer was known as a person or a job title. He or she would perform calculations and do sums. But Lebanese understood that it was a waste of people's time, as the same operations could be done with the help of machines. And soon after that, the word computers began to shift to machines rather than people. Forward to 1642, the abacus evolved into the first mechanical adding machine, built by the mathematician and scientist Blaise Pascal. He invented the first mechanical calculator. It was fully mechanical, can be manually controlled by turning gears. Inspired by Pascal, in 1694, Lebanese made the step reckoner, which were able to perform all four arithmetic calculations. This design was very successful and used for the next 3 centuries to calculate big problems. Unfortunately, the real-world problems required many steps of calculation, and the step reckoner was very slow to perform, not to mention very expensive for many people to own. Forwarding to 1820, Charles Babbage, aka the father of computer, noticed that computations consist of similar or repeated operations. This inspired his first design, the difference engine, which were able to perform computations based on a fixed instruction set and even had a primitive printer. The machine was able to approximate polynomials as well. Unfortunately, Babbage stopped working on the difference engine in 1830 to pursue his second idea, the analytical engine. The analytical engine was known as the general purpose computer, unlike the devices which came before it. It could be given data, run operations in sequence, and even have a memory. Ada Lovelace was known as the first programmer who wrote the programs for the analytical engine. The design of the analytical engine sparked the first flames of building a better computer in the future. Starting the era of electromechanical computing was the need of updating the US Constitution Census. By 1880, the US population was booming and the census took around 7 years to compile for all people. Inspired by Babbage, in 1890, Herman Hollerith made the first electromechanical computer known as the Census Tabulator. This machine would read the US Census data from punch cards and tally them up the numbers in order. Hollerith's company was very successful and was called IBM, which is still here today as well. This machine lowered the time to compute the census by a significant amount to around 2.5 years. In 1936, Alan Turing proposed the concept of universal machines, later dubbed to be the Turing machine, capable of computing anything which is computable. Up to this point, machines were only able to do certain tasks that the hardware was designed for. Also in 1936, Konrad Zuse invented the first programmable computer. This computer used punch cards to read instructions and perform operations accordingly. The machine also used Boolean logic and binary to make decisions. The use of relays were common at that time. Relays are like water taps. They had an electric coil which attracted the metal arm and completing the circuit. There was a control wire which controlled the flow of electricity. It was connected to a coil which would magnetically attract the metal arm, completing the circuit. But this was very slow. In 1937, the Harvard Mark I was made by IBM entirely by the use of relays. But the problem with the relays were they had mass, and for this reason they could not move instantly. And we all know that anything that have mechanical in nature have the problem of wear and tear. So relays had to be changed regularly, which had been damaged. The last problem was it was very slow. For example, the Harvard Mark I's timing was it could do 3 summations per second, multiplications took 6 seconds, divisions took around 15 seconds, and complex and trigonometric functions took over a minute. In 1947, Grace Hopper found the first computer bug, which were literally a moth, which was dead in a malfunctioning relay. In 1943, the vacuum tubes era marked the beginning of modern computing. The technology was fully digital, and unlike the relays used in previous computers, were less power hungry, faster, and had no moving parts. The ABC was the first computer that used the power of vacuum tubes in 1937. And in 1943, Colossus was built, which was fully programmable, naming it the first programmable digital computer. In 1946, Electrical Numerical Integrator and Computer, or the ENIAC, was completed. It had around 18,000 vacuum tubes and was very large in size. Vacuum tubes were a huge improvement over the relays, but they would burn down and had to be replaced. Thus, in 1947, the first transistor was invented. This accelerated the advancements of modern computer, and till this day was considered to be the greatest invention of all times. We will learn more about transistors in the next video. I'll see you then.